Complement is basically means not in A. For example, I have S equal to 1, 2, 3. All the subset, that means the powers of S will be this bunch of things. Some set are complement of each other. For example, 1 and 2, 3. What does it mean? It means I have a set. This is my S. So this complement looks like what? I have a set like this. Think of it as a cake. I cut them, and these two parts, if I join them back, it gives me full set. So this is called complement. So suppose my set is like this, and if I cut it like this, so now I have 3 sets. Okay. If I just take these two, I do not form the whole set S. So 1, 2 is not complement to each other. So that means 1 and 2 is not complement each other because they do not form the S. The whole S and nothing are complement of each other. Yeah, it's the same as I take this as my first set and nothing from my second set. Does it constitute to this? Yes. Now we have union and intersection. Basically, it's just a set version of N and OR. The bracket should go here. This means is it be this guy, okay? So for example, I have a set like this. Then A or B is just 1, 2, 3, 4, 2, 3, 5, 8, 10. But set we do not count repeated stuff. So that means the 3 repeated we don't care. The 2 repeated we don't care. So we just write the unique thing. And for intersection, that means N. Only 2 and 3 exist for both. So it's 2, 3. And then disjoint. X intersect Y is nothing. Then we call it disjoint. For example, I have a set called O, stand for odd number, 1, 3. And I have a set called E, stand for even number. Odd number and even number have nothing in common. So it's empty set. And then difference. So I have this slash. This means any X in A and X not in B. So this is like subtraction. And with this, we can also have some symmetric difference. Oh my gosh, so many stuff, so complicated. So later on, we will have picture, then you will understand what the heck is going on. A and B means this area. A or B means either in A or in B, right? So they're both figure. A set subtract B means everything A but not in B. So I remove the stuff in A that is belong to B. Same for B subtract A. Okay, this is called what? This is called A delta B, or A symmetric difference, or symmetric disjoint, which I call symmetric difference. Is what? Is A union B as a set, and then set subtract the set A intersection B. Wow, so complicated. Look at the picture, then you understand. Basically, it's this guy opposite. Okay? That's why I write a bar here. The bar means opposite. Okay? And then this is what? A or B, or A union B. If you use logic, this is A or B. A or B is like everything, right? Then if you do the opposite, that means nothing, empty set. And then here are some funny stuff. If I have a set E, I give a set E, and then I have X and Y, a subset of E. If this is true, we call them co-disjoint, and we have some partition. Basically means I have a bunch of what? Subset, and I take the union or all of them, give me back the E. Then it's like split. Okay, these two, let me just tell you deeper. You don't need to care about too much. This one forms the basis of something called combinatorics, and actually I will teach combinatorics in the other class for the math for the CS student. And now here's the funny thing. This is called Minkowski sum. A plus B. This addition is not simple addition, so we give a name called Minkowski. Okay, Minkowski, if I remember correctly, is the teacher of Einstein. Divide this. It means any A plus B, that A belong to A, logic N, B belong to B. So this is a picture. What the heck? So I have a coordinate, right? So this is 0, 0. This is XY plane, okay? X and Y. This coordinate X is 1, Y is 0. This coordinate Y is 1, X is 0, and this coordinate is 1, 1. I have a B, so I have 3 coordinates, right? This 0, 0, 1, 0, and 0, 1. Now I want to add them. What's the definition of A plus B? All the possible A plus B. That's it. All the possible A plus B. It will include what? It will include the biggest 2 numbers add together and also the smallest 2 numbers add together. What are the smallest number? 0, 0. So the smallest number here is this guy plus this guy, which 0 plus 0 gives me 0. So in the end, I will get 0. Let's consider the biggest guy here. Biggest guy in the Y direction. So the biggest possible value of Y is 1. And here, the biggest possible value of Y is also 1. So the biggest possible Y I get by adding 2 sets will be 1 plus 1 is 2. So this is the biggest possible value here. And the same logic, I have the biggest possible value here. Now, what about if I add 1, 1 to this point? It gives me what? It gives me 1, 1 plus 0, 1. This is vector addition. 1 plus 1 is 2. So I have x1, y2, x1, y2. I have this point. So this point plus this point is this point. Then in the same logic, what about this point plus this point? This point, let me use green, plus this point. It will be, this is 1, 0, 1, 0, plus what? This is 1, 0, 1, 0. then I will get 2, 0. X is 2, y is 0. Oh, it turns out this point plus this point, it gives me this point. Okay, then what about this point plus this point? Okay, green plus star. Green plus star is 1, 0 plus star is in blue, right? 0, 1. So it gives me 1, 1. 1, 1 is 1, 1 is here. Okay, so this point plus this point is this point. Okay, and then you try all the possible way to add stuff. For example, this point plus this point, you will raise the y value by 1, so you will raise to here, so you will get this point. So that means this point plus this point, that means this corner plus this corner give you this corner. Okay, then that's why square plus a triangle give you something like this. And let me tell you, this is where things start to get crazy. What about a star at a triangle, a parallelogram at a circle at a diamond, a heart at a circle? That's called geometry. And this is defined geometry by set theory. So that means everything is just set theory. And then previously, we talked about the logic law. We have the same thing here in the set, just different notation. It's the same thing. So now that's it for the set. And what is your homework? Try this at home. Yeah, for example, is C a subset of D? Let's look at it. C is nothing. There's one thing called nothing. D have two things. Nothing and an empty bracket. So first of all, yes, C is in D. Why? Because these two symbols are the same thing, and we don't care about the same thing twice. So C actually is D. And by the fact that any set is a subset of itself, so therefore C is a subset of C, which is the same as D. So this guy translate to this guy, so we have this. Okay, let's check the last one. V and union of W. V is 1, and then set 2, 3. W is 2, and set 1, 2, 3. Then we just combine all of them. 1, 2, and then 2, 3, right? 2, 3, and then 1, 3, right? 1, 3. Okay, yeah, which is this. Okay,